Hi, it's Laura from Gridcog and I am back with another video on ancillary services in continental Europe. This time I'm following on from Ashok's video where he explained how you can model FCR and aFRR in Gridcog. I am going to build an actual project with assets trading in these markets to show you not only how to set up a project like that, but also how ancillary markets get taken into account in our results. First, let's start with designing a project in our planning module. For simplicity's sake, we will build this project as a very large 100 megawatt front-of-meter battery, let's place it in Germany, with no other assets on site and a grid connection of 80 megawatts. On the site meter, we can select the historic market data from the Gridcog library that we want the simulation to be based on. In this case, let's use 2023 data and select FCR, aFRR up and aFRR down. When we open this library item, we can have a look at the assumptions that sit behind this market. The Gridcog industry team has pre-configured FCR, aFRR up and aFRR down markets by indicating the service type, direction and preserve intervals. For each of the services, we have also defined an acceptance percentage of 50% and an energy utilization rate of 10%. What this means is each time the battery deems it attractive, it will bid into the defined ancillary markets. The simulation will then assume it gets accepted 50% of the time, and each time it gets accepted, 10% of the bid will actually be activated. Lastly, we have set trading block durations to reflect market regulations. In this case, we have defined trading blocks of 4 hours. When our customers want to model this, they might have their own assumptions on these numbers. What you can do in this case is clone our market library item and change the numbers as you see fit. Back in the project designer, there are a few more settings we have to set on the battery to fully reflect market regulations. Bid rounding has to be set to 1 megawatt, as this is the minimum size of capacity that is accepted into ancillary markets. If we were modeling a behind-the-meter project and there was an aggregator involved, we'd likely be able to reduce this number to 0.1 megawatt and bid smaller increments of battery capacity into the markets. Next, we set how much of our battery capacity will be registered in the market. In this case, let's say we can register 90% of our battery capacity. Lastly, we have to define our energy duration requirement. This number defines the battery footroom or headroom that is able to export energy to or absorb energy from the grid. Let's also focus on the ancillary tab. Here we can click through various days of the year and see how our battery interacts with the markets. For example, let's have a look at June 10. You can see at first in which interval a battery imports or exports energy. The second and third graphs show how much theoretical capacity the battery has available to bid into pre- and post-fault markets, and the fourth graph shows how much actually gets accepted. Comparing this profile to the price curves, you can see how the optimization bids in the battery capacity according to the best price signal. For example, whenever FCR is higher than the sum of the aFRR up and down prices, it will bid into FCR. This is because FCR is symmetric and blocks out opportunity for any other market participation. Whenever FCR is lower than the two aFRR markets, it will choose to bid into aFRR. Modeling your battery assets' participation in ancillary markets is a difficult task. Luckily, Gridcog simulation engine is well equipped to model those markets and therefore allows you to reliably estimate ancillary revenues. Thanks for watching and see you next time.